Good day, everyone. In continuation to our lecture last meeting for Module 1, Unit 2, Design Requirements for Highway. This is now Part 2, which we'll have to go over with design speed. So, when it terms to design speed, defined as the maximum safe speed that can be maintained over a specified section of a highway when conditions are so favorable that the design features of the highway govern. So, how does a particular vehicle or type of vehicle behave when it comes to a highway? So, ito yung ating limiting speed to limit accidents and to avoid overcrowding of highway. So basically, design speed must be maintained for the entirety of the highway if terrain condition or some obstructions would not allow this. The design speed may be reduced to 10 to 20 kilometers per hour adjacent to sections. Lalo na dito sa Baguio, mountainous sections, ang ating roadway, napaka-steep ng kanyang super elevation. So, we will always need to impose design speed on curvature of highway. It is the basis that will literally put shape to the different elements of the highway. So if we then specify signages that tells us that this will serve as the limiting speed or the design speed for this particular horizontal alignment, vertical alignment, or highway, it will definitely help us design the barricade, the supporting elements of a particular highway. So pagdating sa barricade, sa safety precautions, sa number of stoplights, sa number of safety signages, and so forth and so long. Design speeds are designated for different types of roadway. So, as an example for our table specification, this is now a table that dictates the design speed for various road classes and terrain conditions, and dictates the AADT, the annual average daily traffic, and the classification when it comes to terrain. So, for class 1 description, these are now farm to market or farm to market roads, where the volume of vehicles that are passing through or using those lanes are 0 to 50. Then wala tayong specification when it comes to flat terrain, rolling mountainous, and so forth, and so long. And number 2, we have local collectors. Pag sinabi naman natin local collectors, AADT has 50 to 400 vehicles. Flat at 60, rolling at 60, mountainous at 40. And naman KPH design. Then 3, we have major collectors, 400 to 1,000 vehicles. Speed are 480, 80, and 50 for mountainous. Then major highways. So pagdating naman natin dyan sa mga marami-raming lanes, we have 1,000 to 2,000 vehicles at a design speed of 80, 80, and 60 kph. Then lastly, for expressway, vehicles that are greater than 2,000 vehicles per day, we have 100, 170 kph. Though usually hindi naman yan nasusunod dahil nga traffic. Design speed for feeder roads range from 30 to 60 kph. Ministry of Public Highways from 1979 data. Such that the second one is the discussion when it comes to sight distances. Very important ito whenever a driver needs to perceive an opposite vehicle. So how long should the driver perceive the opposite lane whenever there is a curvature? So paano niya masasabi na within 2 seconds probably may darating na sasakyan, or that driver will now have a glimpse of that particular obstruction kung meron mga landslide doon sa opposite side of the road, of the curvature of the road, madali niya makita yan, and it will then give him a decision making process that he or she should then slow down, no? The design speed when designing the alignment of the road, there are two types of sight distances that are normally checked for adequacy. First up is our stopping sight distance, also known as your SSD, and the passing sight distance, which is PSD. Common design procedures are based on SSD. But when it comes to overtaking a left lane or a right lane of a vehicle opposite direction, we then pursue PSD, or the passing sight distance. No? Now, stopping sight distance. First things first, we have the stopping sight distance. Stopping sight distance is the shortest distance required for a vehicle traveling at an assumed running speed to stop safely before reaching a stationary object on its path. So, bago niya mabangga yung obstruction along the way, meron siyang decision time. So, at 2.5 seconds, he or she should then press the brake or press the brake and prevent accidents along the road. Example on this without using the table is this formula where SSD is basically your stopping sight distance, V1 is the initial velocity or initial vehicle speed, which is in feet per second. So while driving on a highway, ito yung ating constant initial speed. Then G is your gravitational constant or the gravitational acceleration, English 32.2 and 9.81 pag metric, no? Then A is the deceleration rate. So ano ngayon yung reaction time ng ating vehicle? And G is your roadway grade, yung inclination ng ating roadway as a vehicle passes through it. No, if it is uphill, that is the positive grade. If it is downhill, that is now a negative grade. Divided by 100 for percentile rating. Then T sub R is your perception. Ito na yung sinasabi nating reaction time. How does a driver react on a opposing obstruction or an opposing vehicle? No. So at 2 seconds na perceive na niya may susunod na sasakyan. Lalo na kung gabi nakita niya yung headlight and it is now nagfi-flicker siya for that it will turn to the right or to going to the right lane or the opposite intersection lane, then madali niya makita, no? Within 2.5 seconds, ito dapat yung speed mo, ito dapat yung skidding mo. And the road design that we will later on consider helps the vehicle to sustain that particular speed and that particular perception time or reaction time. So when it comes to stopping sight distance, we have here standard tables. So kung hindi naman natin usually kinocompute yan, ito lang naman yung ating standard. Under stopping sight distance, design speed for miles per hour, brake reaction distance, braking distance on level, and stopping sight distance calculated and designed. So if your initial speed or design speed on the roadway, on that roadway is at let's just say expressway at flat of 80 miles per hour, the brake reaction should be at 294 feet before intersection or before curvature. So, at 294 distance, dapat bumabagal na yung movement ng sasakyan mo, no? At nasa 80 miles per hour na yung speed. Beyond that, you will then expect accidents. So, braking distance on level, ito ngayon yung bago ka mag-brake at a distance of 614.3. So you can immediately perceive the opposing vehicle. Then the calculated stopping sight distance should be at 908.3 feet and a distance of at a design of 910 feet. Then these are some ulterior or these are some tawag na dito, alternative equations that we can use on stopping sight distance, especially if the grade was not given and the actual time perception and as well as A over G grade. So ito naman yung alternative equation for SSD, which is the distance 1 times distance 2. Distance 1 discusses the decision distance. So dito ka ngayon gagawa ng reaction. So at this particular distance, magbe-brake ba ako? Babagal ba yung movement ng vehicle ko? Should I speed up or should I slow down? Then at D2, after you have decided whether you are going to speed up or not, this is the time whether you are going to brake or not. Then at this particular distance, D2, this is now your braking distance. Where D1 is the distance traversed during the perception plus the brake reaction time. Brake reaction time consists of perception and the time about 1.5 second reaction and an action time of 1 second. Napakaliit lang, no? At 1.5 second, dapat nag-iisip ka na. At 1 second, dapat nakapag-decision ka na. Then at exactly 2.5 seconds, you then immediately move to the braking distance. So D1 is now equal to the initial velocity V times the actual reaction time of 2.5 seconds, T, over 3.6. Para saan yung 3.6? Halimbawa, naka-English unit yung iyong V at saka T, yung velocity, yung conversion natin yan. Yung 1 over 3.6 converts velocity in English unit into metric unit of kilometers per hour. So 1 over 3.6, direct conversion na po yan with kilometers per hour. Then D2 is the distance required for stopping after brakes. So eto ngayon yung pinaka-distance mo para tumigil, no? To perceive and tawag na dito, to identify whether there are opposing vehicles, no? Required stopping other brakes are applied. Short distance is required when the negotiating on uphill. This is taken care by the sign of gradient G. So, kung pataas ba yung kalsada or pababa. Now, this is now computed by the formula of initial velocity squared over 2 times G, which is the acceleration due to gravity, times 3.6 raised to 2, that is with refer to the conversion of English to metric from feet per second, feet per second to kilometers per hour, then the friction, F, and the grade, G, where V is the running speed or the initial velocity in kilometers per hour, the reaction time, T, which is at minimum of 2.5 seconds, the G is 9.81 meters per second squared or 32.2 feet per second squared, and the coefficient of friction, which is between 0.30 to 0.40 or 0.29 to 0.40. Minimum yan na. Then G is the gradient, whether the road is uphill or downhill. Positive pag uphill, downhill, negative. Okay? So, first thing is your decision site distance. Ano nga bang decision site distance? The decision site distance has general guidelines. So, in the general guidelines of decision site distance, you should then stop on rural highway within 3 seconds. So, in standardly or statistically, that is 2.5 seconds. But with regards naman to the different types of highway that we're going to consider on our designs, though, first thing, general guidelines, we have stop on rural highway. If you're going to stop on a rural highway to conduct decision on site distance, that should be within 3 seconds. Stop on urban highway, that should be on 9.1 seconds. Speed per distance change on rural highway should be between 10.2 to 11.2 seconds. Speed per direction change on urban highway. So parang ito na yung papalit-palit ka na decision kung may dadaan ba o wala. 14 to 14.5 seconds. In other areas, interchanges and toll plaza, that is mainly of 2.5 seconds. Now, in consideration, in some instances, DSD may, or the decision site distance may not be economically feasible. In these cases, the use of suitable traffic control devices should be provided. So, lalo na kung crowded, ang daming intersection, mayroong pedestrian lane, mayroong sidewalk, and so forth and so on. At marami pa. That's the time you'll then have to provide ang tawag na dito, traffic control devices. Your stoplights, your signages, your minimum requirements for stopping, your humps, and so forth and so long. Then we have minimum stopping site. When it comes to minimum stopping site, distance is normally computed for wet pavement condition. So may difference yan. Kung dry yung ating pavement or roadway, ito dapat yung speed. Kung mabilis naman, ito dapat yung mas mabagal. So we have then consider minimum stopping site distance if we have a wet pavement. The design speed, which is in kilometers per hour, between 120 to 20 kph. The running speed, yung actual speed natin, should be at 102 to 20. The actual velocity is at 85 to 100. The friction requirement is at 0.29 to 0.30, and so forth and so long. If not, you can then interpolate na lang. Then the required SSD should be within 210, 160, and so forth and so long. So halimbawa, nakuha nating design speed is at 110, no? Lumabas na velocity is at 85 also. 85, 110, then 29. Then friction is at minimum of 0.29, pero ang ginamit natin 0.30. And we have computed that is 175. So 175, so dapat eksakto natin yan, change natin si friction, change natin si velocity, change natin yung actual speed and at a distance of 210. So, ito ngayon yung magiging new value niya and magiging reference design values natin. Now, for design speeds greater than or equal to 80 kph, the running speed is taken as 85% of the design speed. For design speeds less than or equal to 30 kph, for value of design, speed is assumed for running speed. Okay? Example on stopping sight distance is this one. The design speed of vehicle is at 80 kph. Assume total reaction time of 2.5 seconds. Hindi niya sinabi kung rural or urban highway. So basically, standard highway lang tayo. Two-way, two-lane. Normal roadway at 2.5 seconds reaction time. The coefficient of friction is at 0.35 between 0.30 and 0.40. So pasok pa yung ating standard friction. If not, we then have to consider either 0.30 or 0.40. Kung 0.42 yan, bawasan natin, gawin nating 0.40 based on standard specification on the AASHTO requirements. Then the road is in the falling gradient. So pababa daw yung kalsada at 5%. So negative 0.05. Calculate the safe stopping sight distance. Ano ngayon yung SSD natin? We can either solve this by the first formula or the second formula. Now, for our solution, note that the given speed or the initial speed of the vehicle is at 80 kph. So if we then have to convert that in meters per second, 80 kph times 5 over 18. Standardized na natin, conversion ng kph to meter per second is 5 over 18. Para hindi na tayo mag-decimal. Diretso na yan. 80 kph to meters per second, we have 22.22 meters per second. The reaction time required is at 2.5 seconds. The coefficient of friction given is at 0.35. The gradient is going down, so negative 0.05. Using our general formula, initial velocity over 2g, A over g is basically F. No? Friction po yan. Coefficient of friction is basically A over g. Kaya F na yung binigay na dyan. Substitute lang natin, 22.22 raised to 2 all over 2 times 9.81. Kaya natin kinonvert sa 80 kph into meters per second dahil yung ating G dito ay naka meters per second square. Then unitless yung ating friction at saka yung ating gradient. But gradient is at negative downhill. So 22.22 square over 2 times 9.81 times the friction 0.35 minus the gradient of 0.05. Bakit minus? Downhill. Falling gradient. Plus the initial velocity of 22.22 meters per second and the reaction time of 2.5 seconds gives us an SSD requirement of 139.43 meters, or basically that is 139 meters. Okay? Ito ngayon yung stopping sight distance natin bago huminto at makapag-react yung ating driver kung merong obstacle and may opposing vehicle. Okay, 139 meters. Actual 139, no? Or 135 para eksakto. Pero in terms of our solutions, later on, gamitin niyo yung with decimal. Para eksakto tayo, no? Now, the passing sight distance is the minimum sight distance required on a two-way highway that will permit a driver to complete a passing maneuver without colliding with an opposing vehicle and without cutting off the passed vehicle. So without ang tawag na dito, without overtaking, without overspeeding, without collision, and so forth and so long, minimum speed natin is as designed based on two-lane and two-way. Did you know that the number of vehicles passing through a two-lane and two-way highway is at the minimum standard capacity of 2,400 vehicles per day? Ba? You'll never know without looking at it, no? Without basically investigating the highway, the number of vehicles passing on it, diba? Basically, as you go on, parang oonti lang. Pero if we count it properly, there are basically 2,400 vehicles. Imagine 2,400 vehicles in one day. Paano pa kaya pag 6-lane, 2-lane, di ba? Napakarami. Okay? As part of sight distance, we also have other options, which is your passing sight distance. This is how vehicles should intercept an opposing vehicle along a highway or overtake a vehicle from a right lane. Now, for two-lane highways, passing sight distance is the shortest distance required for a vehicle to safely pull out of the traffic lane. Lalo na kung maluwag yung kalsada, kailangan mong mag-overtake. No? This is not the required distances on which you can perform overtaking or passing a vehicle. No? Vehicles safely pull out of the traffic lane, pass a vehicle traveling in the same direction, and return to the correct lane without interfering either with the overtaken vehicle or opposing traffic. An example figure, this is how do we interpret the data for passing sight distance. For passing vehicle, ito yung constant speed, ito ngayon yung mag-overtake the vehicle. Of course, meron tayong minimum distance at which an opposing lane vehicle should collide or should not collide with the overtaking vehicle. No? Opposing vehicle appears when passing vehicle appears at point A. Dapat magsalubong sila at that specific distance up until vehicle A overtake the other vehicle. No? So, kailangan natin si distance 1, 2, 3, 4, and 2/3 of distance 2. So, this is how do we identify them. Distance 1, basically the initial maneuver distance. Dito ka ngayon gagawa ng decision. At this distance, mag-start ko na yung flicker ko, pupunta na ako sa overtake. Ganon. Then, D2, the occupying left lane distance. Ito ngayon yung distance mo for you to perform the overtaking. Okay? D3 is your clearance distance. Clearance distance is your allotted distance before collision. No? So, first phase, ito yung distance niyo ni A and B. Then, before collision, dapat ganito yung inyong distance. Bago kayo magbanggaan, dapat nakamove ka na dun sa tamang lane. No? Then, D4 is the opposing vehicle distance. Then, this is now the allotted distance for the opposing vehicle to travel before collision of the overtaking vehicle. No? And where D1 is the distance traveled during perception and reaction time and during the initial acceleration to the point on encroachment on the left lane, where D1 is your initial velocity VO times T1 over 3.6. Again, yung 3.6 natin, conversion po yan from English to metric. Plus the acceleration times T1 squared, yung reaction time mo yan, all over 7.2. Mali yung nasa module, pakipalitan po yung 2, that's supposed to be 7.2. Kasi na-distribute yung 1 over 3.6. Dapat 7.2 yun. Okay? So, VOT1 over 3.6 plus AT1 squared over 7.2. Then, D2 is the distance traveled while overtaking vehicle occupies any part of the left lane opposing lane, as shown in the figure kanina. D2 is your initial velocity T2, yung overtaken vehicle, times T2 over 3.6, where T2 can then be specified between 7.6 to 11.4 second reaction time. Then D3 is the distance between the passing vehicle at the end of the maneuver and the opposing vehicle. Ito na ngayon yung makikita natin na distance bago mag-collide yung opposing vehicle with the overtaking vehicle, which is between, based on the design requirements of AASHTO, should be between 15 and 80 meters only. Beyond that, there will be an impending collision. Then we have D4, which is the distance traversed by an opposing vehicle for 2/3 of the time of passing vehicle occupies the left lane, where D4 is basically 2/3 of the second distance D2. Now, important assumptions whenever you are performing passing sight distance or designing passing sight distance. First is for you to overtake the vehicle travels at uniform speed. Don't forget that. Constant speed. Once you have changed your speed, you will then change the equivalent time of perception and reaction, and as well as the equivalent distance on D3 and D4. As well on D2. Kasi pag bumagal ka at beyond that, babagal din yung isa or mag-speed up yung isa, and then collision will eventually happen. The passing vehicle has reduced speed and trials the overtaken vehicle as it enters the passing section. The passing vehicle accelerates during the maneuver and its average speed is at 10 mph, miles per hour, higher than the overtaken vehicle. And lastly, when the passing vehicle returns to its lane, there is a suitable clearance length between it and the oncoming vehicle in the other lane, which is your D3, by yung 15 to 80 meters. As a standard table, we have here a table for passing sight distance values for different design speeds. No? Comparing these values with SSD, the requirements for passing sight distance is about 2 to 3 times that of SSD. Okay? While it is absolute to provide, pag SSD kasi, obstruction, then opposing vehicle. Pag PSD, ito yung overtaking vehicle, no? How to maneuver when it comes to obstruction, when it comes to overtaking, and so forth and so on. While it is absolute to provide SSD all the time, it will be very expensive to provide PSD all the time, as this would mean very gentle horizontal and vertical curves. In practice, PSD should be provided in long sections of roads that drivers will have the opportunity to overtake one-third at a time. Okay, the passing sight distance values for different design speeds. For instance, we have the overtaken vehicle of 100 kilometers per hour. The overtaker should have a speed of 80 kilometers per hour at an acceleration of 0.66 meters per second square at a perception or reaction time of 4.5 seconds. Distance 1 should be 113 meters. T2 should be at 11.4 seconds. D2 is at 317 meters. D3 is at 80 meters maximum. And D4 should have a distance of 211, where the PSD is 700 meters. And the minimum PSD should be at 500 meters. Okay? Important design consideration when it comes to designing PSD. Okay? The range of speeds are affected by traffic volume. Okay? So, kung mas maraming lane, mas maraming volume ng vehicle. So, mas magiging mahirap yung design speed natin when it comes to passing sight and stopping sight distance. Then, mas masikip na kalsada, mas mahirap mag-overtake. No? Low volume, few vehicles need to pass. Then, high volume, few opportunities to pass. So, kung mas kukunting vehicle, mas maraming opportunity for passing. Then, high volume, mahirap magkaroon ng passing site passing site expectations. No? Should provide as many as passing sections as possible. Then, yun napapasok yung ating mga parking space. Allotted overtaking space dun sa mga gilid-gilid, kung saan pwede tayong tumigil kung merong sira, and kung saan pwede tayong mag-overtake, mga ganun ba. Then should not be confused with other warrant used for designing no passing zones. Okay, the important design consideration shouldn't or couldn't, ito naman yung does and do's and don'ts natin. Overtaking a vehicle is easier for downgrade segments. Ay, naku po, disgrasya yan. Lalo na pag mapababa, tapos may opposing vehicle, nawalan ka ng preto, kalagitnaan ng grade, patay. Need to provide longer passing sight distance for upgrade. In mountainous terrain, it may be more economical to provide for a climbing lane. Though we cannot do that. Marami yan sa Netherlands and sa Switzerland as well as Norway. Meron silang climbing bike lane kasi medyo steep yung road, then gagamit sila ng rail line for the bikers to make parang sasampa sila doon para iakyat sila ng rail line na yan. The number of passing opportunities greatly affects the capacity of your facility. Now, as an example, nagkamali ako sa animation. As an example, we have here the given speed of a passing car. Yung ating V1 is your 96 kph, kilometers per hour. Speed of our overtaken vehicle is at 88 kilometers per hour. So, ito yung mag-overtake at yung i-overtake. Time at initial maneuver, yung speed nung maneuver nung ating overtaker, which is 4.3 seconds. Average acceleration niya is 2.73 kilometers per hour per second. time passing vehicle occupies left lane, yung opposing, which is your 10.4 seconds. The distance between passing vehicle at the end of its maneuver and opposing vehicle is at 76 meters, which is your D3. Yung paano yung before collision ng car B with the overtaking vehicle A, no? First things first is for us to compute D1. The distance traveled during perception and reaction time during initial accelerations. So we have initial velocity of overtaken vehicle of 88 tawag na 88 kilometers per hour. The speed is at 4.3 seconds over 3.6 plus acceleration of 2.73 plus the time of 4.3 seconds over 7.2 gives us D1 of 112.12 meters. Kaya may 3.6, no? D2, distance traveled where overtaking vehicle occupies any part of the left lane. That is between 7.6 and 11.4. Given sa ating problem is 10.4 seconds. Dito na natin, ito na yung opposing vehicle, ito na yung overtaken vehicle, 96 kph times 10.4 over 3.6 gives us 277.33 meters. Ito na yung before collision, D3, which is should be between 15.80 and given sa atin is 76 meters. And lastly, we have a D4. Kamali ako dyan. So D4 naman yan. That is 2/3 of D2. D4 is basically the 2/3 of D2, the occupying distance by the opposing vehicle. 2/3 of D2, which is 277.33 times 2/3 gives us 184.89. Summate lang natin si D1, D2, and D3, and D4 gives us the passing sight distance of 650.34 meters. And the minimum passing sight distance should be the 2/3 of D2 plus D3 plus D4. Yun lang naman yan. No? Don't forget, ito po, passing sight distance is computed as 650.34 meters, or basically that is 650 meters to maximize safety. And minimum passing sight distance is the 2/3 of distance 2 plus distance 3 plus distance 4. Yun lang naman po yan. And yeah. So after sight distance, we have here your minimum radius of curvature. So how do we compute and design minimum radius of curvature? Based on the super elevation, the steepness of the mountain, the friction on the pavement, the velocity on the car, and so forth and so long. And that will be discussed on our next lecture video for Module 1, Unit 2, Design Requirements for Highways. Bye-bye.